Hi, everyone, and welcome. Aaron Smith and Nancy Bakeman with EBA here. And if you're joining us in the live stream or if you're listening in a recording on the EBA Academy or on our Better Homes, Better Future podcast, welcome to you. We're joined by our good friend and partner, Joe Nebbia from Newport Partners. And we're really excited to continue the second module of our code series. Today, we'll be focusing on Climate Zone 1 and 2 window requirements under the new codes. Joe, welcome. Always great to see you. And I think I see you and Nancy the most of anybody I've seen during COVID.
I'm glad to be on that list.
I'm glad to have you on that list.
So I think everybody should see my slides now, if that's correct. And thank you for the nice welcome. I'm excited to be here today, and we'll talk about both window and insulation requirements for climate zones 1 and 2. So if you're not here for that, I hope you enjoy it anyway. This is part of an 8-part series that we're doing on the energy code. It's module 2. So you'll see we already did module 1. If you missed that, that's an introduction and overview of the structure of the energy code and the different compliance path options. Today, we're here on module 2. Again, that's the window and insulation prescriptive tables in the code. Next week, we're going to be talking, if you build in different climate zones, we're going to talk about climate zones 3, 4, and 5 on Tuesday, and then climate zones 6, 7, and 8 on Wednesday. And then we'll follow up in January with 4 more modules: insulation, installation, air sealing, ducts, HVAC, hot water, and lighting, as well as some controls. And then finally, the last module is performance path options, where we dig a little bit deeper into those different performance paths and also talk about the new additional efficiency packages in the 2021 International Energy Conservation Code. So that's our schedule. All of these are going to be recorded. So if you miss any one of them, you can always go back and watch it. And I encourage you to watch all of them, although modules 2 through 4 really just you need to watch what climate zone you're building in, obviously.
Yeah, good advice. Yeah.
And Aaron, you're gonna please feel free to stop me if we get questions. Type them into the question or chat function, and feel free to stop me as we go.
Will do.
For you attendees who are on, we're going to do a few quizzes as we go, just to make sure the information is getting in correctly. This QR code you see here, I'm putting it up now for a few seconds. If you want to do the quiz with your phone, you can just, use your QR reader on your phone to get in now. And when I get to that slide, it will automatically activate for you. If you don't have something with a QR code, you can go to slido.com. You see that there on the left of the screen, and there's a code for our specific set of questions. It's good to get in now, because as I go, again, when we get to the actual question, you'll be ready to go, and it will pop up either in your browser if that's where you're entering, or on your phone if you're using that QR code.
And just a note for people, you do need to do this on your phone. You cannot click on the screen.
That's right.
That's right.
Or type in slido.com in another window in your browser, and you can get there that way. But yeah, you can't click on the screen, but it will work to hold your phone up on this screen and use the QR code. So looking forward to using that as we go through. Just a quick recap. We covered this in the last module, but it's relevant to how we talk about the code requirements. When we talk about insulation and window requirements, they're really trying to do one primary thing, and that is to control the movement of heat across the building envelope. That's what the energy code is concerned with. And that heat movement across the envelope can be happening in multiple ways. The first is conduction. That's when heat is traveling by touch across a surface. So think about the hot oven. If you touch it, that's heat moving through conduction. Convection, where heat's moving by air, and then radiation, and that's Radiant heat movement is how the sun heats the earth. And so we try to control the heat movement in these three ways. Most of you who are familiar with building science will understand these concepts, but just wanted to mention those, and I'll talk about how the code requirements are trying to control those parts of heat movement as we go through. For the most part, the insulation and window tables are trying to control conduction. Convection is controlled by air sealing requirements separately in the code, and then some radiation with solar heat gain coefficients on windows. Again, conduction, this is the primary thing we're concerned with insulation especially, and also windows. And that's where heat is going to want to move across the building envelope from where there's more heat to where there's less heat. So if in climate zones 1 and 2, it's going to be hot outside and cool inside with our air conditioning. So this picture would show more of a northern climate, but imagine those temperatures aren't really reversed, right? So maybe you keep your house at 70 and it's 85 outside. That heat is going to want to move from where it's hot outside into the house. And our insulation is going to try to prevent that heat movement by resisting the heat movement across that building envelope. It's going to stop the conduction. So heat naturally wants to move from more to less, and the insulation is there to stop it from doing so that we can control our internal temperature. When the code talks about things like R value and U value, it's important that we understand those. So R value is resistivity to conductive heat movement. The higher the R value of an insulating product, the more resistive it is to heat flow. So that's important as we think about the code requirements for R value. So if the code says I need R13, that's a measure of how resistive that insulation is to conductive heat movement. U value is the inverse, it's conductivity. So it's how well does heat move across a substance. So U value, lower is better. And in Windows, we typically talk about U value. And then we can also talk about U value when it comes to the whole wall or roof or basement type assembly. So when the code talks about R value, it's talking about labeled insulation R value. So I have a R13 bat of insulation and it's labeled that way, or I blow in a certain amount of insulation and my product has an R value per inch that's been tested. It's an R5 rigid foam board insulation, something like that. It's labeled amount of R value. It's not a effective R value when the code talks about R value. U value is an effective conductivity because it deals with the whole assembly, framing, windows, framing, any kind of interruption in that insulation, or with windows, it's going to deal with the whole window U factor. Today, as we talk about the code requirements found in the table, we're really living in the prescriptive path of the code, and 2021 code doesn't use the term prescriptive, so it's important to point that out so you don't get confused. But it's still the path in the code you choose if you're not doing one of the performance options. So we find these tables in the code that tells us how much insulation we need, what kind of window we need, and how well those items have to perform, those components. We also have several different ways that the code allows us to comply using these different tables. The first, I talked about the insulation R values. Again, that's a labeled R value amount. The next is an assembly U factor or U value. You might use the assembly U value if you have an insulation that doesn't meet that R value, but does meet the U factor or U value because of how it's installed. So maybe you've got a R value in a SIP panel, structurally insulated panel, that the R value doesn't meet the code requirement, but because it's continuous, the U value does meet the code requirement. So that's an option for compliance. And then finally, there's the whole building UA, and I'll demonstrate how to use this later in the class, where you can trade off the U value requirement based on an area weighted average. And as long as you're meeting the UA target for the whole building, U times area, you can change around how you're doing your insulation and windows. Maybe move some out of the attic and into the walls, or vice versa. Maybe have better windows and less insulation, or better insulation and worse windows. All of those are options in the UA calculation. All of those are found within the prescriptive path. It's not a performance calculation. So that's important to know. There are tools out there that will do a UA calculation, and I'll talk about that a little bit more when we get to that demonstration. So for window requirements, which I'm going to cover first, and again, feel free to interrupt me as we go. I want to talk about the climate zone separately, and also how the code has changed throughout the years. In your specific state, you might have a different code. So I'm talking about the national code, the IECC, the one that's made as a model code. And I've got the different additions here in case your jurisdiction has adopted one of those models. You can see that throughout the years, we haven't seen a lot of change in Climate Zone 1 for window requirements. That first column there, the U value, in 2009, there was actually a maximum U value. Again, lower is better for U value. But in 2012, we moved to not required. So there's not currently a U value target for windows, a conductivity target in Climate Zone 1. And Climate Zone 1 in the US is really just southern tip of Florida in the continental US anyway. So it's not a lot of area that's being covered by this, but there is some amount. And the reason that there's no conductivity value is that the outdoor temperature compared to the indoor temperature is so similar. There's not a lot of change in temperature, delta T, between outdoor and indoor. And so there's not a lot of drive for heat movement to make better insulating windows more cost effective. There is a requirement for solar heat gain coefficient. And there is also a skylight U value. So if you're putting in skylights, there is a maximum 0.75. That's a very high U value for a window. It's very easy to meet that. So it's not an aggressive target at all. The solar heat gain coefficient, though, is how the window attempts to control radiant heat movement across the building envelope. So again, radiant heat movement is how the sun heats the earth, and we have some amount of radiant heat entering through the building envelope into the home, especially through our windows.
Right. That's the whole idea of passive solar, right, Joe?
That's correct. Yeah.
Right.
So if you're in a northern climate, not climate zones 1 and 2, you're heating your house using that solar energy that's coming through the window. You can do that, and it takes some careful design so that you don't have rooms that aren't too hot and that sort of thing. But that is an approach to designing an efficient home in the north. In climate zones 1 and 2, we tend to want to keep that solar radiation out of the home because it's going to heat up the home more, and our air conditioning is going to run. And that's why the code has a actual solar heat gain coefficient target. And again, lower is better is probably the wrong word with SHGC. Lower means less solar heat gain through the window. So in 2009, we had a 0.3, and that has gotten more stringent starting in 2012, but hasn't changed since then. So 0.25 solar heat gain coefficient. Sometimes what you'll find is that the lower solar heat gain coefficient windows also come with a decently low U value. So you will get some insulating performance out of a lot of these windows, despite the fact that the code doesn't require it. But that is a requirement for a 0.25 solar heat gain coefficient in the prescriptive table. The next column there, that's not actually in the table, but I include it because it should be on the NFRC sticker, and that is the air tightness of the window. It's not part of the blower door test, which tests the whole building envelope. This is the air tightness tested in the factory of the window itself. And in all climate zones, it has to be 0.3 CFM per square foot. So that's something to note. It should be on the NFRC label in any home that's built in an IECC jurisdiction that's adopted the IECC. It's not always on the label, so it's important to make sure that air tightness target is there. And that's the way the code controls convective heat across that window assembly air leakage actually through the window itself. Now, I'd like to talk about climate zone 2 windows, where we see a little bit more stringent requirements as far as U value goes. You can see from 2009 to 2012, the U value of vertical fenestration or non-skylights went from a 0.65 to a 0.40 U value window. And 0.40 is pretty easy window to get out there. I think, some statistics I've seen is that 0.32 to 0.35 is very common. 0.40 you can certainly get. So it's not an incredibly insulating window or a market leader. But again, in climate zone 2, we don't have a huge delta T, which is why the window requirements are not extremely aggressive as far as insulating requirements. Also, you can see that the skylight U factor changed in 2012 to a 0.65 from a 0.75. So these values are something you need to look on the NFRC sticker for and make sure you're lower than that U value, because lower is better. Like climate zone 1, the solar heat gain coefficient also moved to a 0.25 starting in 2012 and hasn't changed since then. So your windows have to be 0.4 or lower on the U and 0.25 or lower on the solar heat gain coefficient according to those tables. And I'll talk a little bit about some of the flexibility around that as well. Very important as if you're trying to get a home to comply with the energy code, that the NFRC sticker is on that product when it's inspected. It is a mandatory item in the code. It's required regardless of your compliance path. The NFRC sticker has to be there and it should show the U factor, the solar heat gain coefficient, and the air leakage in order for the code official to know whether that window meets code or not. In this case, the 0.3 U factor would meet code, but the 0.30 solar heat gain coefficient would not meet code. So this, as a straight prescriptive compliance, this window shown here, the sticker would not meet code because of the solar heat gain coefficient. And so either the performance path or something else will need to happen in order for this home to comply. If you don't have the NFRC sticker on your window, and this is important, you'll be forced to accept default values for your window. So if you have a vinyl double pane window in climate zone 2, say, you're going to end up having to assume a 0.55 U factor, which doesn't meet the U factor requirement in the code. And then you'll be forced into one of the other compliance options. So again, that's why it's important to have that NFRC sticker there. If you don't have it, the code assumes that you have this kind of worse than code window, which will end up causing you compliance issues. Not really an issue in climate zone 1 because there's no requirement there. But if you've got a really good window and you're trying to do, say, a UA trade-off or a performance calculation, you want to take credit for that and not assume a badly performing window. There are a number of ways that you can comply even if your windows don't quite fit all the specifications. So let's say I have a window that's a 0.42 and a solar heat gain of 0.3. That's fine as long as all of my windows aren't like that, because I can use a few different trade-off options. I've got the whole building UA, so maybe I've got better insulation. And again, I'll explain more about that concept in a minute. That will make up for my windows being worse than the U factor. That doesn't help with the solar heat gain coefficient, but we'll get to that in a moment. I can also do an area weighted U value calculation just of the windows. So that's a UA calculation, but takes out the walls and attic insulation and things like that. And it says, okay, this one window, maybe I didn't have the sticker for, and so I had to take the default U values, but all my other windows had the sticker, and some of them are better than code. And on an area weighted average, my window complies. And so that's allowed in the code. You can also do the same thing with solar heat gain coefficient, area weighted average. You might see this more if you are doing some sort of passive solar design where I want high solar heat gain on maybe a south facing window that's under an overhang or something like that. So I'm getting heat in the winter, but not in the summer. Again, not really probably a consideration in a lot of climate zone 1 and 2 locations, but it is possible. So if you have a window that doesn't meet the solar heat gain coefficient target, you can still qualify prescriptively using an area weighted average of that solar heat gain coefficient across all your windows. There is also an exemption for a window and a door up to a certain square footage, 15 or 24 feet, depending on which one you're doing, where you can simply exempt that from your calculation. So I can, maybe I've got a decorative window or something like that that's not labeled, it doesn't meet the requirements at all. As long as it's less than 15 square feet and my other windows comply, I can exempt that. So there is some amount of flexibility that's built into the code. The IECC has always had a certain amount of ability to do something different if it doesn't apply to your specific situation. But there are limits on how far you can go on that. So keep in mind that there's some flexibility, but it's not unlimited.
Joe, a great question just came in is where exactly in the code does it give these exceptions? And this person works on a lot of additions and remodels in climate zone 2.
Sure.
And sometimes they want to reuse a window in the new addition. And some building departments will require that the window meets current code. And without a sticker, you have to use the default. Maybe what's your advice around that type of a situation?
Right. Yeah, well, first I'll show you, I'll get out of my presentation real briefly and just show you the some of the exceptions here. You should see me scrolling through insulation requirements, and we should.
I don't see you scrolling, Joe. I just see.
Oh, that's right. You know what? I think I'm sharing my.
Yeah.
I think I'm sharing my presentation, so I'm going to go to screen, and that should help. Okay, so now you should see it.
Yes, we see it.
Yes. Okay. So there's different exceptions found here. The section to look for is R402.3. That's the 2021 IECC, so it might be a little bit different. Here's the U factor area weighted average, SHGC area weighted average as well is in 402.3.2. Again, those numbers might be a little different in your jurisdiction if there's amendments or anything like that. 15 square feet exception here in 402.3.3. So that's in the section that deals with the building envelope, and that's where to look for those specific exceptions. If you're dealing with renovations and that sort of thing, there's a different set of rules, and so you want to go to chapter 5. So this is 402, that's chapter 4 of the residential IECC. Chapter 5 is the chapter dedicated to existing homes. And that chapter has additions, alterations, and repairs. If it's an addition, you're going to have to meet the current code.
Right.
It's just not really any way around that. There's still some exceptions to that, not related to windows with ducts. You know, if you're adding a few feet of duct and it's under a certain amount of linear feet, but not a new HVAC system, then you might not have to meet the duct requirements. But for the envelope requirements, you're going to have to meet those if you're building an addition. If you're building if you're just replacing windows, those new windows will also have to meet the code. If you're renovating in a way where you're taking out a window and putting it back in, like you talked about, kind of reusing that window, the issue with that is there's a lot of interpretation that's available there. And one thing I always stress with any discussion about code is the local jurisdiction has the final say on pretty much everything. So if you're unsure, ask the local jurisdiction what they're going to have you do ahead of time so that you can plan. It's a little bit of a gray area because the code says if I'm taking out the window, I'm going to need to bring it up to code. If I'm replacing windows, they need to be up to code. If I'm not replacing the window, but I am altering it by taking it out and putting it back in, I think a strict read of the code would be that would be okay to leave that same window. Maybe you're doing some cleanup work around the frame or something like that. But if the local jurisdiction says you have to replace it, then that's going to be the answer. So check chapter 5 for those details on alterations and repairs. But if the local code official says we want you to put in a code compliant window, that's just what you have to do. But again, I do think a strict read of the code would be that you could remove the window during a renovation and put it back in its place without having to upgrade it according to code.
Great question, Catherine. Thank you so much.
Yeah, thank you. Okay, so we have our first quiz here. So if you've logged into Slido already, you should have this pop up. If not, there's a QR code there on the screen, or you can type slido.com. Again, you can't click on it because it's not a dynamic link, but type slido.com and there's the code there. So I'll give you a moment just to get in case you haven't, and you can answer this question. The question is, in climate zone 1, the 0.25 solar heat gain coefficient requirement is intended to stop what type of heat movement?
And just remember, you can't click on the screen. You need to do it in a separate browser or on your smartphone.
That's right. Okay, I'm just going to give it a moment more, and then I'm going to move on. I think probably most people who have answered are going to answer have answered. So radiant heat movement, that is correct. So solar heat gain coefficient is intended to control the movement of radiant heat across that window. So a lower solar heat gain coefficient is going to stop more radiant heat from crossing that window. A higher solar heat gain coefficient is going to allow more radiant heat in. Next question, in climate zone 2, the U factor, the 0.40 U factor window requirement is intended to stop what type of heat movement? Okay, just give it a moment longer. And the answer is conductive heat movement. So we had at least one answer that was convective. Convective is air moving. So that's where we're going to see the air sealing requirement for the window, that 0.3 or lower. The U value is conductivity. So that's stopping conductive heat movement. So again, conductive heat movement is that, you know, the hot temperature outside touching the glass and wanting to conduct across that glass. And the glass, the U factor is its ability to stop that heat movement from conducting. Next question, true or false, a window with a U value of 0.35 and a solar heat gain coefficient of 0.38 would comply with the window requirements found in the prescriptive window tables in the code.
And Joe, that's for climate zone 1 or 2, right?
Yes, that would work in either one. The question will work for either one, yes.
Okay.
And these questions aren't meant to be gotcha questions, but they are meant to tell me whether I need to go back over a concept or not. Okay. And the answer, well, we got kind of a split there. The answer is true. So actually, I'm wrong by my answer. That would not comply.
No, it doesn't comply because it
yeah,
doesn't meet the solar heat gain coefficient of 0.30.
Right. So I've marked the wrong correct answer here, but it doesn't meet the solar heat gain coefficient, and so would not comply in either climate zone.
Correct.
So ignore the green, please, and the people who chose false were in fact correct. Don't worry, you're not getting a score. Otherwise, I would fix your grade. But yes, the 0.35 U factor would comply, but the solar heat gain coefficient would not. It would be too high.
Right.
Okay, hopefully I marked the correct one on this one. True or false, I can comply with the code using an area weighted average for window U value or solar heat gain coefficient, even if some of my windows are worse than the values listed in the prescriptive tables. Okay, and everybody said true, and that is correct. I can use that area weighted average. So not all of my windows have to be compliant, just enough of them that my area weighted average passes. So that's it on Windows for now anyway. If you have any questions about Windows or about any of the installation information we get into next, please feel free to keep asking them as we go.
One question we had come up, Joe, is impact glazing. Since we're talking to a lot of our friends in climate zone 1 and 2, obviously we have the Miami-Dade, the Texas Department of Insurance, many other local requirements. How do they look at U factor, or how do they look at the window code in those particular jurisdictions?
Right. Yeah, and I could not find any current exception in the code for impact resistant glazing. I do believe there may be some local amendments that deal with that question and acknowledge that some impact resistant glazing may be less focused on U value and more focused on hurricane resistance. Obviously, we're going to pick a life safety issue over the U value of the window. But I do know that there are many main manufacturers who have hurricane windows that are also meeting these U values. You might have a harder time with some of the U values required in the more northern climates, but we don't have as much issue anyway with hurricanes there. There's other high wind events, of course, but yeah, impact rated glass you can get in a low U setting, and I'm no window expert, but my understanding on a lot of the high impact glass is that there's like a sheet of poly between, essentially a layer between two sheets of glass. And what happens in a low E setting is that you essentially have double that. But I was looking at a manufacturer just the other day that was showing their low E, low U factor window, and it was also impact rated for hurricane zone. And it was a major manufacturer, so that they are out there.
Thanks, Joe.
Okay, well, this is our climate zone 1 insulation tables in the code. And you can see over on the right, basement, slab, and crawl space R value. There's no insulation required according to code in climate zone 1 in the foundations. It doesn't mean it's not a good idea to do it, but the code doesn't require it. So that's important to remember. Foundation insulation can get a little bit tricky sometimes with termite issues, and you have higher termite incident areas as we get further south. So that's something to consider. So it will certainly improve the efficiency of your structure if you do insulate the foundation, but it's not required according to code. Where we do have requirements is in the ceiling, wall, and floor. Now, the attic hasn't changed in any of the code editions since 2009. It's been an R30. It's a fairly typical attic assembly. It's been that way forever. So hopefully builders are used to doing this. So that's an R30 in the attic. In wood framed wall, the only change has been to add an option. Now, climate zone 1, which again is Southern Florida, you don't see a lot of wood framed walls. You see a lot of block construction. But if somebody was doing a framed wall in Florida, they would have to have an R13. It's a very common that it fits in a 2x4 wall. And again, that's a labeled R value amount. So it's not effective R value or any of this discussion where you put, somebody says, well, my radiant barrier gives me an effective R value of something. That's kind of a little bit nonsense when it comes to conductivity and resistivity. But this is a labeled R value, an amount of insulation in the wall. And 2021 IECC added another option, which is a 0 plus 10. And when the code for the wall says 0 plus 10, that means R0 is in the cavity, nothing in the cavity, and R10 continuous exterior insulation. So that's probably going to be like a rigid foam or something like that. So the code now specifically calls out that R10 as another compliance option if you don't want to do cavity insulation, even though you've got a wood framed wall. That was already allowed by the code in these previous years, but what they've done is put a prescriptive example of another assembly to make it easier for the builder. I could still have gone to the U value table or the UA and used a continuous R10 and still complied with the code in previous years, but now it's actually in the table. It's meant to be helpful to provide some options there. But I want to talk really about the mass wall, because that's going to be where a lot of our climate zone 1 construction is actually going to focus. So I've got the definition of the mass wall a little bit later, but think concrete, poured concrete, CMUs, ICFs, anything that has a thermal mass to it. And then there's a 3/4 R value requirement. And what that means is the 3, that first number, is if more than half, 50% plus of your insulation is installed to the exterior of the thermal mass. So if you have a mass wall and I have 50% or more of my insulation to the outside, then I only need an R3. and the code is giving some amount of credit to the thermal properties of that mass wall. If I have more than 50% installed to the interior, then I have to do an R4. So that's what that 3/4 means. There is a footnote explaining that in the code. If you ever forget, do I need 3 or 4? Might be somewhat academic depending on what type of insulation you're installing. But again, if you have 50% or more to the outside, you get an R3. More than 50% to the inside, you have to put in an R4 as a minimum R value. So that's like an inch of EPS foam, maybe a little bit less than an inch of XPS foam, just to give you some context for how much insulation that is. And it's an assembly that we see a lot in Southern Florida. R value for floors is an R13. That's only floors over unconditioned space. So if I have a garage, the floor above and with a bonus room or something like that above the garage, that floor over unconditioned space, the garage would have to be insulated to R13. Again, that fits in a 2x4 cavity. So it's pretty easy to fit that in there. It's not a lot of insulation, but there is some amount of required insulation so that we stop heat conducting from the unconditioned space below up into the conditioned space. And that's the Climate Zone 1 tables. Again, there's no R value requirement for basements, slabs, and crawl spaces. Most builders in Climate Zone 1 are going to be looking at that R30 for the ceiling and the mast wall R value there. There also is a table that gives U value requirements. And so if you don't have an assembly that fits with one of these specific things, maybe you've got a wood framed wall and you have a different R value amount. Maybe you've got a different framing factor, a lower amount of wood interrupting the insulation. You've got wider cavities, that sort of thing. You're using advanced framing and you want to take credit for that. That's going to give you some amount of bonus in the U value calculation because you have more insulation there. Again, if you have some combination like a flash and bat where you've got a certain amount of one type of insulation and another, sometimes people will use a U value because they can calculate it easier. If you have a combination of continuous and cavity insulation, maybe you've for some reason have done an R11 cavity with a R3 continuous. You can then calculate the U factor for those products and see if you are compliant. One thing that I'll point out in this table is that you'll see a change where you don't see one in the R value table, see a change in the wood framed wall R value or U value, excuse me, those should all say U value in Climate Zone 1 because this 0.084 is different than the 0.082 for a wood framed wall with R13. And what happened is between 2012 and 2015, somebody did some calculations and argued at the code hearings that the U value credit being given for the R13 wood framed wall should be a 0.084 instead of a 0.082. And that was a convincing argument at the code hearings. And so we realigned the U values given for wood framed walls. It's not more or less stringent, really. It's saying that an R value performs at a different U value than what used to be in the tables. So just something to point out. It's really only relevant if you're doing a UA calculation and probably not even then, as it's a pretty minor change. For Climate Zone 2, we do see some more requirements and some more changes, and there's a couple that I'll highlight. Again, no foundation insulation required in Climate Zone 2. So here we're talking about most of Florida, parts of Georgia, Alabama, Louisiana, Mississippi, Texas, Arizona, New Mexico, sort of the southern part of the United States. A lot of it is climate zone 2. None of those states have their entire state in climate zone 2. However, you see some 3, 4, even up to 5 in Arizona. But significant portions of the states will be in this climate zone. So the big change we see in this climate zone is in attic insulation. In 2012, we went from an R30 to an R38. And then in 2021, we moved from an R38 to an R49. The R49's been required in the colder climate zones for some time. It's now required in climate zone 2. So that's more insulation that would need to be in the attic if you're using these prescriptive R value tables. The same change happened for wood framed walls, where we now have a 0 plus 10. Again, that plus 10 is a continuous number. So that would be if you had some sort of continuous insulation on the exterior of the building. And then the mass wall R value requirement's a little bit higher than in climate zone 1. So it's 4, R4, if 50% or more of the insulation is to the exterior, and R6 if there's more than 50% to the interior of that mass wall. So that's important. You're still going to see a lot of block construction in climate zone 2, but as you get into some of the drier climate zones, you also see quite a lot of frame construction as well. So that R13 may be seen more often. Again, that's going to fit in a 2x4 wall. Or you might see some of the equivalents like a SIP wall or an ICF insulated concrete form wall, something like that. Again, floor value only for over unconditioned space. The R value is R13. So that's an amount of insulation. And again, I can't stress this enough because it does get very confusing in code compliance. Effective R value is not a thing in the code. Labeled R value is a thing. U value is where we start to take in things like drywalls, air films, framing factor, how well that wall performs as an assembly, a whole assembly. The R value is just talking about what's the label on the product say it is. And that product has to be tested according to FTC rules. It can't just claim any R value, which does happen with some of the less scrupulous products out there where they're claiming an R value that's not actually according to the FTC tests. For U value, again, this is where you might go if you want to do something different. One example, and you wouldn't see this often in residential construction, is maybe somebody wants to do an above deck rigid foam for roof insulation. Again, that's more of a commercial application, but maybe somebody wants to do it, or a SIP roof or something like that. Then they have to go for the U value target rather than that R value target, because it's a continuous insulation at that point and it's not interrupted by framing. Likewise, if you're going for a framed wall and you have some other combination, the example I used before was an R11 plus 3, where R11 is in the cavity and R3 is on the outside. You could do that U factor calculation and comply with the code in that way. If you want to build with a mass wall, again, there's a lot of that in climate zone 1 and 2. Here in climate zone 2, we're looking at an R4 or R6. It has to meet a certain material requirement, and the code lists a number of things here: concrete block, concrete, ICF, brick, not veneer, mass timber, things like this. I want to point out the ICF because that actually gives you quite a lot of flexibility in the code. If you look at R4 or R6, most ICFs I've seen are about R22 with 2 layers of R11 or something like that in there. They might not be that exact amount, but the point is you're going to have quite a lot more insulation than is required by code if you build with ICF in the South, or in most climate zones. Actually, you're going to have more. And that means you're going to have a major benefit on your UA, which means you may have some flexibility somewhere else in the envelope if you want it. So that's something to keep in mind. Some of these more innovative products do give you that flexibility where maybe the code doesn't quite fit what you want to do. There's also if you're not one of these mass wall as defined by the code, you can use this calculation, this equation, to determine whether it's a mass wall or not. But most of these, I think this captures pretty much most of what would be used in that situation.
Joe, we had another quick question come
Yeah.
up on insulation.
Mm-hmm.
So this attendee says they have had inspectors tell them when using 2x6 framing walls that they need to fill it up with insulation, which
Yeah.
would be more than R13. Their interpretation is to use R13 as long as the insulation is held toward the interior of the wall. Is there something about that in the code? And she is aware of the exception for existing homes that don't have enough space for the required R value.
Right. Yeah, it's the code only gets at that possibly through a how should I put this? Indirect route. So the code does require that all insulation materials be installed according to the manufacturer's instructions. So if you had an insulation manufacturer that said this should be installed without any air gaps, for example, then you could possibly be in violation of code compliance because it's not installed per the manufacturer's instructions. But that would have to be in the manufacturer's instructions. There are good reasons to fill the cavity, but you don't always see a cavity filled. One example might be if you're using spray foam, where a certain amount of spray foam can be applied in one layer. And then it sometimes can't be applied. It can be applied again in a second layer, but it's more expensive because you have to come back in and respray. So sometimes for people using a high R value closed cell spray foam, something like that, they might not fill the cavity.
Sure.
My read of the code, and I'm giving my opinion here, is I don't see anything in the code that requires the cavity to be filled.
Mm-hmm.
Now, if I'm building a 2x6 wall, I think I would want to take credit for the amount of insulation I can get in that wall. R21 is going to be more expensive than R13. I get that, but you can certainly make a better performing wall if you're already doing 2x6. So I don't know all the economics of different pressures of what's going on in that situation specifically, but it certainly is possible to build a better wall if you fill it. But I don't believe that the code, again, local jurisdiction, if they tell you to fill it, you got to fill it. But
Right.
I don't believe that the code actually says that.
Right. Thank you, Joe.
A couple of notes. If you're using the U value table for climate zone 1 and 2 for mass walls, that you cannot have a mass wall that's worse than the U value listed here. So you have to have, basically this is saying that you can't have a mass wall that's much worse than the code if you're using UA. So 0.17 and 0.14, those are actually slightly better targets than you get if you're using, I'm sorry, that's if there's more than 50% of the interior. So the reason that's there is if I've got a 4.6, again, the 6 is if there's more than 50% to the interior. The U factor in the code, the 0.197 or 0.165 in that table is equivalent to the R4 to the exterior. So what the code is saying is if your installation's on the interior, you have a different maximum U factor, and it's 0.17 or 0.14. And that's supposed to be equivalent to that R6 or R4, depending on whether you're in climate zone 1 or 2. So that's actually a footnote in the table to keep in mind. A couple of quick things, again, if you're in climate zone 2 and all of a sudden you've got to put in an R49 attic and you don't want to change from the R38, the code does say that if you've got if you use a raised heel truss, so you can get full depth insulation, you can do a R38 across the attic as long as it's R38 uncompressed in the whole attic and over the top plate at the eave. So if you can extend uncompressed that R38 all the way across the attic and over the top plate, then you don't have to do the R49 and you can still do the prescriptive table. That's just a picture of a raised heel truss. That makes the attic perform better because it's not being compressed at the eaves. Likewise, if you're doing a cathedral ceiling or something like that, the code does allow a small amount of space to be only R30, still doing prescriptive and not a trade-off. It's 500 square feet or 20% of insulated roof area, whichever is less. So this might be a good option for an addition in an existing home point of view, where maybe the slope of your roof on the addition isn't going to give you room for the R49. You can go down to an R30 for just a small portion of the roof. This is an example of a cathedral, ceiling, a vaulted ceiling where you don't have an attic space. Again, you can't do that R30 for the whole attic, though. We are running a little bit short on time here, so I'm going to go through this part quickly. This is just an example of how to do a UA calculation. It's something I find people often don't understand as if they don't deal with code a lot. But a UA calculation is just an area weighted average. So it's what's my U value times the area of that assembly. And I'm comparing the required area weighted average to what I'm actually going to do. So here you see for windows a 0.4, this is a climate zone 2 example. I have 180 square feet of window, and therefore my UA allowance is just that window U value times 180 square feet. That's my allowance. Likewise, if I've got a mass wall and I've got to have a 0.165, I have 2,600 square feet of wall area, and I have a UA allowance of 429. Again, it's just multiplication. We do the same thing here. I built it on a conditioned crawl space and a ceiling. And so this is the required UA, U times the area of the building envelope that I would need. And I need to be equal to or less than that. And then I can do whatever I want. In this example, I've got better windows, so I have a lower UA on my windows. I have the same walls as are required by code. I've done the same thing on my conditioned crawl space, and then I've gone down to I believe that's an R38 attic insulation, and so I've got a slightly higher UA for my attic, and we can see from the calculation here I'm still compliant. So just by putting a slightly better window in, I was able to change from an R49 to an R38 in my attic in this example. It's a very simple example, but that's essentially how it's done. Just real quick, in climate zone 2, there is some flexibility to go down to an R19 in the attic for a thermally isolated sunroom and up to a 0.45 U factor. So if you're doing a thermally isolated sunroom, you have some flexibility there as well. Aaron, do you want me to
one quick question before we get to the I love the quizzes, by the way, but so this is one of our builders down in Texas, and he says that we only do roofline insulation in spray foam. How does that change the R value compared to attic insulation per code?
Yeah, so that's always one of the hardest things to calculate. So typically you're trying to meet the R value, right? But so it doesn't change that R49 in climate zone 2 that you would need. So that's in an unvented attic. You're doing the roof line and you're insulating there. So you need an R49. If your spray foam, if you were spraying enough to cover the trusses at the ridge line, then you would have some amount of continuous insulation uninterrupted by framing. So if you're only doing in the cavity, then you're going to have to meet that R49. If you spray enough that you've then got a continuous layer below that ridge line, you may be able to do a U value calculation and get some amount of trade-off there. More than likely, you're going to have to do a UA compliance because spray foam's expensive and you're not going to put a ton of it in the ridge line. So you're going to do add insulation in the walls or better windows to do a UA trade-off and comply there.
Great, thank you.
And Aaron, I can wrap up if we're at 4, or I can go a few more minutes.
No, let's finish up, Joe.
Sure. Anybody who needs to leave is welcome to leave and watch the recording. First question we have here, climate zone 2, the mass wall R value of 4.6 means what? All right, I don't want to spend too much time waiting on these ones. So I'm going to go through them pretty quickly. Okay, the answer is R4 is the requirement if 50% or more of the insulation is located to the exterior of the mass wall. R6 is if it's 50% is to the interior. That cavity versus continuous is a split that you're going to see in the framed wall category. If I used a raised heel truss in climate zone 2, I can install what level of insulation as long as that level of insulation is uncompressed across 100% of the attic and over the top plate at the eave. So this is if I'm using a raised heel truss, what's my R value in climate zone 2 need to be? Okay, we've got a fair amount of answers. R38. The R30s, if I have a ceiling without an attic space, I can go down to an R30 only for a portion of the roof. But the R38 I can do in the entire attic if I can get it uncompressed at the eaves. True or false, I can install more attic insulation and better windows than required by code while installing less wall insulation than required by code, as long as I have a whole building UA better than or equal to the code required UA. That's a lot of words to say I can do a UA trade-off. And everybody's got that, so that's good. I'm just going to run through these real quickly because we are at the end of time. This is just a few innovative examples of what builders are doing around the country to insulate their walls. This is rigid foam. In this case, it's to the interior. I'm not sure if this building had it also to the exterior or not. So this would be the wood you see here, I believe, is furring strips for attaching the drywall and that sort of thing. So I believe this is a concrete block wall, but I'm not positive about that. And then you need an R6 if it's in climate zone 2 to the interior, or R4 on the outside. This is an open cell spray foam, I believe, and I think this is climate zone 2, but in Arizona. So this is a wood framed wall, and they're using a spray foam in the cavity. This is part of a flash and bat system. So they've sprayed a small amount of closed cell foam, and then they're going to add bat insulation in the rest of that cavity. This is an exterior rigid foam. All the joints and seams are taped. That's important. I think this one's in Georgia. This one is a insulated structural sheathing. So it's both structural and insulated, and that's a system that does that, and so it's getting that continuous insulation to the exterior. This is an example of a double wall. You're probably not going to use this a lot in climate zones 1 or 2, but it basically works. You have 2 stud walls, and then you blow in insulation, and in between the stud walls, you essentially create a layer of continuous insulation, as opposed to the exterior. It's in the middle of the wall, but it does create a thermal break. Here's another picture of a double wall. This is a SIP panel, structural insulated panel, where there's insulation between 2 structural boards. It could be OSB, plywood, there's metal ones, magnesium oxide, I think, is another material, but there's a lot of different SIP walls, and they are used a lot in the South, or that's where they're used a lot, I guess, in the country. Another picture of a SIP. This is just blown in insulation, nothing terribly innovative, but it helps to fill the cavity pretty well. This is an ICF wall. So this is actually in New York, but again, in climate zone 1 and 2, this would be a mass wall, and it would give you a lot of flexibility on your other assemblies as far as what you could do, because it's much better than the code requirement for R4 or 6.
And I'm sorry, Joe, that's an ICF, right?
That's right, insulated concrete form. So this is 2 panels of rigid foam, and as they build it with the blocks on site, they pour in the concrete, and it forms a super airtight as well as super structurally sound wall, very high wind ratings and that sort of thing.
Absolutely.
And well insulated.
Right.
This is another picture of an ICF close up. You can see where they would pour in that concrete. More spray foam. This is closed cell, I think in Minnesota, where they've done the whole house this way. So here you could see, for the builder who asked about this, I think they're actually covering the framing there at the top. So you might get some amount of continuous insulation value and be able to claim a U value benefit to that, because it's not interrupted by framing in that case. 2 quick questions for anybody who's still on. An insulated concrete form used as an above grade wall should meet the insulation requirements for what type of construction? And we just talked about this. Okay, we've got an answer, so I'm going for it. Everybody said mass wall. That's correct.
Good.
An above grade wall or structural insulated panel with R10 insulation can meet code requirements for which of the following above grade walls? This would be compared to a framed wall in this case. We've got a couple answers there. That's correct. Both of those, an R10 continuous would comply. And there's actually that R10 0+10 requirement in the table now. So that's good. It would comply. And that's everything for climate zones 1 and 2. Again, if you're interested in more climate zones, come back next week. In January, we'll talk about the code requirements for insulation installation and some of the details around that. And I'm excited to keep on talking to you about the code as the next month or so goes by.
Yeah, and if you've just completed this window module for climate zone 1 and 2, then you'll want to click on module 5, insulation installation requirements, to continue your journey with me and Joe.
Thanks so much.
Great, Joe. Yeah, thanks everyone. Great stuff.